Today I'm going to be discussing rotors, how many magnets in the rotor, and the rotor itself, and how important all those components are. It's not just about the magnets. It's really not. Because if it is just about the magnets, then all these rotors that I have here defy the laws of physics. And they don't. It's just, there's a lot more to it than just how many magnets are there. And one of those components is the weight. Absolutely, very important. The only way you can measure the magnets equally is if all the rotors weigh the same. That's the only way. Or, in this case, I can do 9 and 3. So I can do 3 magnets with this one, and I can do 9 with this one, and that's it. But, the reason how I found out that the weight is almost more important than how many magnets is on it is I put 3 on this one, and I put 2 even stronger ones on another one. But this is the problem with this, experiment. It's not really a problem, it's a demonstration of why it's important that all your rotors virtually are the same if you're going to do this comparison. I'd say this one weighs about a pound, 1.2, maybe 2 altogether. This is about 55% infill, this one right here. This one is 15% infill, and with the 2 huge magnets in it, and it weighs 0.75 of a pound. This bad boy weighs almost 4 pounds. It's 100% infill. It's an inch thick. It's got 9 neos in it. Adds up to about 3.75 pounds. And I'm going to show you why that's a bonus and not a hindrance. Especially if you're looking for more speed out of more magnets. It's not even a question, really. I'm going to run all of these rotors at the same amount of electricity. Okay? And to even show you that the amount of power that you put into it doesn't even really matter as to whether or not. Honestly, the best way to run these experiments is to have a rotor that will, each magnet configuration can fit in the same rotor. But I'm doing it this way just to show you that is almost a necessity. All right, so let's turn it on. We'll start at 9. We're going to work our way up to 20 volts. You know what? Start at 12. Or maybe we could keep it at 12. I don't know what we're going to do right now, but let's turn it on. So 12 and a half volts. That's a nice high-pitched frequency. I like that. Okay, so we're going to let this run. I don't think that we're drawing amp on anything at 12.5. Not off this circuit. We got our load right here. It's like something is coming connected and disconnected. Huh. That's all connected. How about this? Turn off the load for right now. Maybe if I undo this a little bit, maybe screw it in. It's not screwed in all the way. Although it feels like something shorted for the load anyway. Yeah, that lamp is a little loose. There we go. We're just letting it build up some speed. We are now drawing, my bad, we're drawing 100 milliamps. We might get to 2. There we go. You can barely see it because the lights above are so bright. Yeah, I don't like that it's not stable. There we go. What is wrong with this thing? The connection might be a little shy here, a little short. So before the next one, I'm gonna screw these in a little better, I guess. Maybe I'll get a different load. All right, let's see if we can put it up here like this. Yay, all right, it's on. Let's make sure it's on. It is going. All right, we're at now 0.2 amps. Oh man, where'd I put my tack? Probably in the other room. Damn, I need that. Yep, there it is. Perfect. All right. So I had the 120 degrees hooked up, and it would go about 15. It's going 1207 right now, 1215, 1225. It's still on the increase. You're now drawing 0.3 amps. Nope, 0.1. Looks different. Almost 1300 RPMs, man. That's going really fast. I'm almost willing to bet that neither one of these rotors will even get that fast. But we will see. 1333. All right. How long have we been going for? Let me look here. Been about 7 or 8 minutes. Hello, hello. What's up, everybody? Nah, it's just some steel ball bearings. All right, so watch this. I'll turn this off now. Power is cut. On off switch. Power is cut. Now, if we waited for that to stop, we'd be here for 15 minutes. This is the benefit of having heavy for your rotor. That's like 3.5 pounds of, it's 2 pounds of plastic and then about 1.5 pounds of magnets. And that's my argument here, is that the weight in your rotor is important. Inertia is important. And I know that, I mean, it all depends on what your goals are, actually. So whether or not the flywheel effect is important. But as for me, I'm advocating that you can make a rotor with more magnets in it that will go faster than a rotor with fewer magnets in it. And I'm going to prove that right now. So we'll say 1350 for this rotor. At 12 volts, 12 and a half volts, 1350. Yeah, that thing is really solid. If it flew off this thing, it would break whatever it bumped into. I'm going to lower the shaft a little bit. Maybe we can get that. And sorry, I apologize for not engaging with I cannot see my comments. I do appreciate comments though, so I will get to you. Maybe not live, but I'll see what I can do. All right, that's good. Now, if anything, this adjustment that I just made is going to make it better for the other rotors, not worse. The only person or the only rotor that did not get the benefit of this adjustment is the green one that I just took off. All right. Yeah, I know. I do want to plug some things into the mud, but I you know, honestly, I'm not trying to be convoluted. You know, I'm just, all I'm saying is anybody can light a light bulb with any of these devices. And the reason that we use light bulbs to demonstrate stuff is because they work. All right, 3-magnet rotor. Here we go. Let's back this off just a little bit because it works better. A little bit of an air gap. It does. It just works better. It'll stop less. It'll not break as easy. All right, here we go. Let's listen for the hum. And there's our light. You'll see there's a lot more pulse in the light with the fewer magnets as well. I think that's a negative. That's not a bonus. I mean, unless all you're doing is indicating when the magnet passes the coil, then it's good for something. But like, the more magnets, the less you'll see the pulse. Unless it's going really, 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 really fast, in which case I think you need a little bit more weight. Same amount of, like 2 magnets, but have the disc weigh 2 pounds like that one does. This one weighs about 1.5 pounds with the 3 magnets in it. All right, so this is 12.5 volts. All right, just so for the sake of the experiment, we're going to move it back in. I'm going to move it as close as we can get it, actually. drawing under 100 milliamps. 1350 was the first one for RPMs. Let's see where we're at right now. We're going to let it run for like 7 minutes. 350 RPMs right now. Maybe not 7 minutes, but we'll let it run until we know it's not going to go that fast. Now, I'm willing to bet that if I did my 9-magnet rotor with 3 magnets in it, just like this one is, that it would go faster than the 9 magnets that are in there now. But this one is never going to get that speed. It's never going to get there. You can leave this running all night. It's already slowing down tremendously. The rate of increase in speed is slowing down. 357. Isn't that the, yeah, the 357. You know what? Just because it's only 357, I'm going to back it up again. Because, you know, people say you put it really close, it's going to give you more speed and more torque. So I'll back it out halfway, and we'll see if we get any more speed. Oh, he's right. We're losing by a lot. Okay. 357 for this one. And that was with it all the way up in your face, kind of like that. And same SG, same amount of power. 357. All right, we're going to cut the power. The light does work, but this is slow. This is tremendously less speed, and I think it's absolutely tied into the weight of the rotor. People say light goes faster. I think light just gives you more control. It doesn't necessarily go faster at all. It just makes you feel more in control. Because it's literally, it won't spin for 15 minutes after you turn the power off because of that exact fact. Oh, I had a thought in my head. But now it's pretty empty. All right, 2-magnet rotor. Very smooth, very close. And just for the sake of everything, since this is going so well, I'll do another test and I'll spin it the other way. Spin it with my left hand instead of my right. Go like this instead of like this. And you really don't have to, it takes one pass of a magnet to activate this thing. It doesn't take, you know, lots of momentum to get it started. It's just really slow, nice touch, and it'll go. I love it, man. The circuit is really, really good. Thank you very much, K Energy Store, for selling me that circuit. $352. So we're already with the 2 magnets higher than the 3 magnets. Oh, I have hope for this one now. Last time I ran it, I put a bearing on the flange. So the flange is this. This ties the pole to the table. And I put a bearing like right on this lip right here. So it's between the rotor and that little flange. But I guarantee this isn't even gonna, it looks pretty sweet. Right around 430. We'll let it go for a little bit longer. But as you can see, man, the green rotor blows all these out of the water. And I'm pretty sure it's just because of how heavy it is. RPMs, that's what I'm talking about. And look at how much this light is flashing. It's like so pulsed, you can't light a room with that. Yep, okay. 430, the other one was 357, and this one was 1350, okay? Same amount of power. The only difference is the weight and the amount of magnets. That's a huge difference. Hey, what's up, man? How you doing? I really apologize for not being able to interact. I don't have any moderators at the current time, and well, what I'm probably going to do the next live is I'm going to hook my phone up to the TV so I can see what's going on. But I never hooked my phone up to this TV yet, so. And I know, this is counterintuitive, man. It goes against everything we know to be true about this stuff. But this rotor is going to be the fastest one. And it's not maglev. I put the maglev on there earlier yesterday, but I couldn't center it right, so. And a maglev on a rotor where the shaft is fixed is different. Okay, it's way different than having it be on the shaft and have the shaft bounce up and down. I'd love to do that, not really, but I mean, I always like to have my shaft kind of fixed. I mean, I do have a design that I wanted to use where the shaft is actually part of the rotor. You know, like this. So the shaft is literally like stuck on the rotor, right? And then we'll go like that, and then I could hook my extra power generators right up to the shaft. The one like the turbine generators. I got a 75 volt turbine generator, or maybe it's making 175 volts. I don't remember. But yeah, and then I put this thing all the way up to 20 volts, and it handled it okay. But I think that's why it's going in and out now. He mentioned that it was a 12 volt system, and I've been running it at 15, 17, 18 volts. I mean, the green, my brother's favorite color is green, and it's kind of like a neon alien green. So I don't know. I think it's pretty cool. So what I had going on earlier sacrificed a little bit of speed, but the amp draw went down even farther as I had 16 gauge coil here and one here at 120s. And then I had it all hooked up to the SG via series circuit. It's pretty sweet. I think it worked pretty well. Got about 1500 RPMs at 25 volts. And it was less than 2 watts to run it. Very efficient in my mind. And I was running, and then I was lighting the light. See that light right now? If you can see it, there's no blinking going on right there. Barely any flashing at all. That you could read with that. If it was a brighter light, like a white light instead of a night light or a black light. And the thing with SG that I don't like necessarily is it doesn't matter how much increase in speed you have. The power that comes out of the SG is directly tied to how much voltage and amps you put in. That's how you get your power out, by putting power in. I like to generate, for lighting light bulbs, I just like basic induction. The magnet passes, you get a little electronic burst. You can light a light bulb like that easily. It won't be like this, though. It won't be all... Actually, yeah, I've seen it like that. All right, I gotta tape this down real quick. The SD circuit is now vibrating off the table. I got plenty of Velcro around here. See, like right now, my former systems would be generating electricity, but it wouldn't be anything like substantial, really. It would just be voltage off of like a 32 gauge coil. But right now, you could be storing that somewhere. You could be putting it in a cap, and the cap could be making a capacitance, and you could run something like that. Now, I need the other piece and put it on the bottom. All right. So my point is that, I mean, even if you think the weight is worthless, the more weight, the faster it's going to go. And the flywheel, it gets out of control maybe a little bit because you got so much inertia going on that you lose control. But you know what? Sometimes that's a good thing, especially if you're just trying to see how fast something's gonna go. All right, that looks good to me. Well, there we go. All right. And I got little devil over there on the end, the gray rotor, the small 4-inch rotor. It goes really, really fast. And these coils, these little like bullet coils, they're like just the size of a rifle bullet, I guess. They hit really, really hard. I mean, and this rotor is so light, and like, it's not actually light. It's pretty heavy for how small it is. It's 100% infill. Little flying saucer kind of thing. And then this coil will light it up, but I don't have a good Maybe I do. Let me look. There we go. I like it. It's stable. It's really stable at 15 volts. Let's get a test on the tach right now. Only going 1207, 1217. All right, it's still increasing speed pretty rapidly. I got myself a stool. Haha. All right, this little devil should work. Oh, God, that sucks. I removed some of these 20 gauge attachments to run that over there. And in light of that not working, I think I'm going to stay away from that for right now. $13.80, $13.81. $13.90. That's still increasing. That's awesome. And I'm going to keep the light attached to the output of the SG because that's what I was recommended to do. You shouldn't start it without something attached to the output or you could blow the system. $14.12 actually. But what I'm thinking about doing is taking the SG output and plugging it into this motor at around 22 volts, 22.2 volts. And I'm gonna probably about 0.2 amps, maybe more, I hope. And we're gonna try and run this motor like so, using the SG output. Man, I keep on flicking it, and it's really starting to take it apart. And since it's an external trigger, I don't think it'll go as, and these are smaller, way smaller magnets. It's gonna take it's just gonna take a little momentum to get it started. And like I said before, like under 17 volts, this won't even start up. And that's just because you got to turn up the input to get more output. It has nothing to do with what's going on right here, really. Your output is based on your input. Now, what is it based on is every time a magnet passes, you get a pulse. That's good. That's more pulses. But as for how much those pulses are worth, you need to turn up the juice to get a bigger pulse. And 12 volts won't even light the light, really. 12 volts won't do anything. Pretty much. I mean, not with my coils. That is another thing. My coils are like half the size of the typical bobbin for an SG coil. Literally, like half of one. Just as big, but like half of it. And I think that's actually pretty good for the magnets and everything, and the saturation levels and all that stuff. I think having the coil not be as fat works better, but I can't be for certain, because I know that you just put more voltage or more current through your copper and you're going to get a bigger field. we're trying to maximize what we get out of this. I'm going to hook it up. I'm going to hook this up. All right, let me do that real quick. What am I going to hook up? I'm going to hook up this. Now there's a diode between each coil, so it is directly flowing in the current. Now I did say I was going to spin this the other way. But that'll have to wait for just a second now. All right, so I got one core in, and these two are air. All right. But they are 16 gauge, so they're not pickup coils. They're in series with the SG power. Oh no, what's going on? It's not lighting up. Something's not right. Uh-oh. Nope, there's got to be like and then if all else fails, I got my trusty manual. Man, that thing it doesn't go very fast, but it'll go, and it'll if you need to have something spinning, that thing works. All right. That's good. That's good. Huh. Why didn't that? Oh, that makes sense. I don't know if that's reason. Oh man, that would suck. I'm glad I have another one if that's how it's going to work. Oh no. I think it's the Velcro that I just put on there, actually. And that isn't going to come off. I wasn't intending on taking it off. But let's see what happens if I just plug this back in. Yeah, there you go. Wonder why that didn't work. Yeah, I'm so glad that the Velcro didn't like pull anything off of there. So we know the one, this is weird. I don't know why this isn't working. I want it to work really bad though. Looks like maybe there's something going on here maybe. Nope. Okay. There we go. I knew it worked. So now the 120 SG at 12. It's a lot smoother, I think, because you got the everything hitting from all different sides at the same time. So we're going to get less shaking in the shaft for one. $675 right now. That is definitely increasing at a pretty rapid rate. 716. I want to kind of run like a test, a race actually, to see if the SG at fit like 15 and one of my big coils, which one will like charge up a cap faster. Like this one right here. It's not a uniform wrap, but it's 22,000 turns in the same direction. So that one will generate some stuff. Can't can't see it. Looking for the other core. Here it is. Ah, bam. All right. What was I going to do with it? Oh, it won't fit. Dang. That's why I put tape on these soft iron rods, so that I can get them fat enough to fit in the bigger holes. Is that, good? No, probably not. And probably good to have a hole that it fit in. That'd probably be optimal. With that being said, I do have an 18,000 turn coil. Virtually the same thing. Here's my little one. Here we go. This one's already got a soft iron core in it, so we'll use this one. We're losing an end though. I'm glad we still have some of it. Wow, having that iron core up that close is not slowing it down a lot. Even with all this so-called torque. $900. Starting to go up again. That, see that 900 RPMs. Wow, the amp draw is up a lot higher than it usually is. It's at 100 milliamps. Gonna get a quick AC reading off of this. $109 being generated from the big coil. Now it's at 126, 128. And I love how stable the SG is, because it's like 128, 127, and it's flat. It doesn't fluctuate. That's great. I think AC doesn't fluctuate, but the DC through a bridge rectifier fluctuates, depending on what you put into it. 18 volts. 135 volts. I have no idea what a camp dump is or how to use one. I mean, I could buy one like I bought from Kay. He knows how to do that stuff, and he can make me one. But, yeah, I don't know. I was thinking about a cap dump, but isn't there more components than just a capacitor? Yeah. I mean, if it was just a cap, then I could do it easily. But there's obviously something that forces it to dump. So I don't know. I would love that. Yeah, to be able to charge my own batteries. That would be fantastic. Um, you know what? I might have to start this again. I gotta find the remote. No, I'm not worried about it right now, but that'd be nice to have. Bum, bum, bum. Yeah, that's kind of a bummer. Because I could have turned the TV on and then I could check. Um, yeah, I mean, you can't even turn this thing on without a remote. I don't think. Maybe right here. Yeah. There we go. Gonna have to talk to my kids. They probably know where it's at. Can't be far. So 150 volts at 18.4 and 1 amp, 100 milliamps. Wow. But yeah, definitely. I've tried the. I've even had a dual SG with battery swapping going on, but I don't have a cap dump, so it didn't work the way I wanted it to. I know what the cap dumps do. I just don't know anything about how to build one. And caps kind of scare the shit out of me too. So it's like, because I had a 120 volt DC cap with 22,000 micro chilling right here. Hold on. All right. But yeah, that probably would have been the key component to making all that work, the cap dome. But I do still have the circuitry to set that up again if I ever get my hands on one. And they do, it's weird what they do when you put them together, but they work. They just don't work the way you would expect them to work. They work like this, kind of. You rarely, unless you're doing a generator combo circuit, you don't have both lights on at the same time. I don't know why, but it just doesn't happen. So you switch it to generator and then they both turn on. And that's probably also because I did not have a load. But here, watch me. I turn this off. Our SG light goes on. Let me turn this light off. And when I turn that off, we got another volt of AC. All right. Yeah, definitely a cab, like, not this, but just one of these would be good, I think. Like that one I have over there on the other end of the table. Maybe it's too much. I mean, this is 500,000 micro and 2.7 volts. So I don't know if this one would be good. I have a 10 volt, 2200 capacitor, and I got a 25 volt, 4700. And then I have a starter cap that's an AC cap, a start cap. It's 1 to 110 volts and 1,000 farad, microfarad. Those, I have 4 of those. But I think, honestly, for me to get tremendous amount of knowledge, I got to do a different kind of live stream. I can't be walking around building stuff all the time. I got to actually be sitting down thinking a little bit occasionally. So me just playing over here, I destroyed 4 or 5 transistors, which I couldn't afford, actually. I couldn't afford that. Now all I have is PMPs and these little doubles right here. And that's what I'm using on the SG right now, is one of these little doubles. It's moving pretty good, but what if I had one of my PMPs with this package, with my MPNs with this package? That would be going even faster than it is right now, because it's a different category transistor. These transistors are like almost fake, whereas the other ones were used for audio, Toshiba audio, not fake. I used to have a Toshiba, man. They were good back in the day. Don't know about now though. Don't know what anybody's doing right now. 20 volts, 0.2 amps. I know we're pushing the circuit right now. We are definitely pushing it. You can tell the light is on, even though the light is on. 60s, 162. And that is very slow. I mean, this rotor at this speed, I take off these two coils and leave it with just that and remove this a little bit. Dude, it's going to be going like 2100 at the end, I'm pretty sure. I got it going up to like 1950. That's 1950 RPMs with this thing. If this decided to bend a little bit, just hypothetically, and this thing flew off, it would go through the freaking wall. Or at least bury itself inside of the wall. You know, it will definitely break drywall. It'll break it. Heck yeah, man. K's the man. And I come over here every once in a while and see what's been at least the last 3 comments. Yeah, K, he's the man. And I am trying to build a small one. So here, get one more. Thank you. Thank you. Is that Gerald? Thank you very much. If you got them, yeah, if you figure it out, man, you let me know. Because right now I'm having trouble just forcing the energy into the battery, and I'm sure a cap dump would actually, you know, push me over that threshold where the energy wants to come out. Even though I have a diode, it doesn't mean that it doesn't want to come out anymore. It still wants to come out. And so I think that the camp dump kind of overrides that initial mechanism that forces the energy out and overrides that. And then not necessarily, it's just stronger than that. And it forces the energy back in. Because I charge it up with just a standard charge off the SG, right? And it would get all the way up to like 12.12, 12.18. It works. But then when you turn it off, all that energy dissipates. It just all goes away. And why? And my buddy told me that it was because your multimeter is hooked to the battery and it's drawing the energy out. And so I unhooked it. Let's see how much is in these right now. I'm thinking it's about 12.75 or 11.75. So they're a little drained. But let's check it. $11.8. Nice. 11.86 on one. And 11.8. They're equal. 11.86. I think it's because they were sitting next to each other. That might be less funny than I think it is, actually. But I think they're leveled off at 11.86. They can be at like 12.5. Here we go. It's trying to clean up a little bit. Yeah, I've checked out his store and he's got lots of cool stuff that I'd love to try. Like this SG circuit though, I don't know if I'd be able to reverse engineer this. It is cool, but I mean, there's some things on the bottom here where you can't really tell what's going on, but it all works. It's like there's just some areas on here where there's like just a big blob of solder, and there's lots of things happening underneath that. Well, I don't mean big blob. I just mean like where was I looking at? Oh, that all looks pretty cool. Like this one right here, this blob right here, it's got like 4 different things coming out of it. And when you go up here, you got a resistor, you got another resistor, you got a light, you got all these wires going to that same spot. And I was like, I'm just gonna leave it the way it is because it's beautiful. And I had that idea where you just got your one coil, and you got your SG on the other coil, SG on this coil, and then each battery would charge the coil, and then each output would do the opposite battery. With the 2-magnet rotor, won't work with this rotor, not at all. You need a 2-magnet rotor for that to work, because you can't have energy being drawn from the battery at the same time you're having energy be put into it. That I know doesn't work. If that works, man, then I'm going to do that. And I'm definitely not going to do that because I know it doesn't work. You can't charge and dissipate at the same time. You can't charge and use the battery at the same time. It's got to be alternating generation and usage. And it works perfectly in my mind, as long as you're generating enough to and I was just trying to cap dump into the battery. Well, it's but you can't do that. Honestly, when I'm thinking about it right now, you can't do that either, because what you want to do is you want to take like a power supply and run your SG, and then the output should charge the battery through a cap dump. That's what you should do if you're looking to just charge batteries. If you, I mean, I guess it should work if you got the cap dump. Alternating charging, like self-charging, is basically what it is. And let me show you why the principle is sound. I don't know if it works, because I mean, I wasn't generating nearly enough. I was spending way more than I was generating, so that it won't work like that. And this is inspired by Mike Does and his alternative energy talks. Okay, let me explain why this principle is sound. And it is. Let's get the BS out of here. All right, so when it hits this coil and lights up this SG, then it lights up this coil. And when this coil's being lit and this coil's off, this battery is charging, because this coil's being hit, and it'll send from there to the battery, and then this coil's being hit, and it'll send from here to that battery. At the same time, this is off. Okay, and the fact that this is off is a good thing. Off, on, off, on, off, on, off, on. You got 2 ons at the same time with a battery, and you're going to have a problem, I think. That's why, you don't. That's why you got to take the batteries out to charge them. And you can't be running your RC vehicle and charging your battery at the same time. Now, I'm not saying there aren't ways to power, other ways to power things. That's totally awesome. And I'm digging with old man. I'm digging the Tesla coils, man. That is That's fresh, dude. And literally lighting the light bulb off the grass, that was pretty clever. Mother Earth has everything you need, I guess. All right, so I do have a little Tesla coil here. I'm going to make sure we get the footage. There it is. It's just a little record player of a Tesla coil. It's just got a needle coming out the top. That's all you really need, I guess. That and a couple caps. The secondary is this copper ring here. So that's pretty sweet. I wouldn't necessarily call it a Tesla coil. It does the same thing as a Tesla coil. It's built like a Tesla coil, but it doesn't look like a huge copper rod, and it does not look like a phallic symbol. It just looks like a record player. So we'll do 20. Wait, I'm going to set this up normal real quick, just so that we can, I don't know. I was having trouble with the other way, so I'm sending it back to one coil. Now it'll be really cool. I think I'm going to do this is I'm going to set up, because I had an identical coil to this, but one of the 30 gauge ends broke off. The one in the middle, the one from the start broke off. So it's like not even enough of a nipple to really clip anything onto. So I'm pissed. This 30 gauge wire is really like thin. It's very thin. But now that I got more transistors that I can use, these little ones, and they're not that bad. They're not really impressive, but they're not that bad. I'm going to set up the dual SG again. And I'm going to see about getting a cap dump, because we are going to find out about charging the batteries simultaneous. You know, we're going to do it like this, dual SG, and we're going to try it at a 40 or 90 degree angle, and then 180s on the rotor. We're going to do it like this. Hell yeah. Great idea, man. That's freaking awesome, dude. It's actually kind of unbelievable how awesome the the wireless transmission of electricity is. Right, I just need the cap dump, right? Yeah, let me see if that coil, the end of that coil is salvageable. There we go. Oh man, if I could get clip on that, that would be awesome. There's just a tiny little nub of a freaking 30 gauge coil strand right here. Goodness gracious. All right, so I have a question. If I just use SG to run it with this one, use this big 18,000 turn 32 gauge through a bridge rectifier to a cap dump, could I run it like that? Because if not, I have to make another coil, I'm pretty sure. I have a feeling like the stuff that comes out of the end of the SG is different. There's a different type of frequency that comes out of this one. Because it's a combination of the interaction of the trigger coil and the drive coil that creates the spike that we're talking about here. I mean, granted, you get a spike from one strand, but the spike you get from two strands is different. Because you get a transformer effect when the two strands are working next to each other, and they do charge each other. They electrify each other. And I've got, what do you call it? Oscilloscope readings that prove that. See, but this is 20 volts, okay? 0.1 amps, 560. I think it's because of the transistor, honestly. But, you know, from what I have been told, this should be moving fast enough to make that look like it isn't blinking with two magnets in it. Because that's what this one does. But yeah, man, I think the two magnet rotor, I think I might make one like this, really heavy, with the two magnets in it. Yeah, that's what I'm going to do. I'm going to make another one, not green, it'll probably be gray, but just with two slots. And that'll be awesome. Or I don't even know, man. I'm confused because I'm told that it goes one way, and everything I do does it the other way. I don't get it. What do I do that makes it so paradoxical? Because two magnets is supposed to have max RPMs, right? 568. And I'm telling you, it's got to be the weight. So that I want to make one, but will two magnets be enough to throw that thing around? I don't know. I think so. I think it'll work. So that'll be a rotor design. Do I need to make it 8 inches? I don't know if I'm going to make it 8 inches for two. I mean, I'll probably make it just for the sake of uniformity. So that, you know, you can, without having to move all the coils around. Yeah, I was just getting into that. The size of the rotor, definitely. But the size of the rotor are all the same. So no, that's a constant. The only thing that's different about the rotor is the weight, the infill. They're all 8 inches. So no, that isn't a problem because they're all 8 inches. And I'm really just trying to compare the other rotors to each other, the magnets, the amount of magnets in the rotor to each other. So yeah, they're all the same size. So yeah, if they got the penalty of a bigger disc, then they all have the penalty of a bigger disc. I mean, I don't want to be talking apples and oranges with everybody, but I'm just right now like figuring out. And yeah, like this 4-inch rotor over here moves like the wind, man. 2,000 RPMs, easy with just these 2 coils. But you know, maybe I could just use this one. Maybe we could try that now just to see if it'll work, and pop out. You know, these 6 magnets just have the 2 on there, like this right here. Heck yeah. And then we'll know for sure, right? And I mean, I'll even put this one up against my 9 magnet rotor. They're both 100% infill. Maybe I'll just leave the magnets on there for right now just to see if it'll work. I don't know how hard it's going to be to take them out of there. And then I got to put them in the right spot so I don't lose them. And yeah, like if the magnets are going to be big, you got to have a big rotor to house them in. That might actually be good. These are N52s too. And they're easier to get out than I first anticipated, so that'll work. Wow, so strong. These magnets are really strong. But they don't have a huge field or anything. They're just really acutely strong when you get close to them. Bingo. All right, let's get these magnets. Oh, man. Oh, damn. Put them over here. Right. Now we'll move this up. Like right there. All right, we ready to test this out? I'm stoked, man. This goes like it goes over there. These are different coils, though. Do it at 12. That was 20. But we're going to start it at 12. See if we can't get it going. I don't know why it's not catching. I think the magnets might be too small. What do you think? I don't know. Maybe if I move it back a little bit. All right, let me see if I got anything on the scope here. Heck yeah, it is beautiful. I mean, when I set it up the first time with the 6 in there, it was like damn. I don't know if it's gonna go though. Maybe if we lift it up a little more. I think we got it. No, it's slowing down. I don't know. I can't tell. Yeah, it's slowing down. $25 volts. Yeah, we got it. Woo! 25 volts though. Like 0.1 amps. Well, how many amps we got? 0.1. Yeah, I had to turn up the voltage to get it to go. But that's because the magnets are so much weaker, I think. $970. 983. Oh, here we go. 991. 1000. Here we go. Here we go. So yeah, the smaller circumference and diameter, radius, it's all good too. Looks like we're gonna cap out at 1093 though. Stable reading. 0.2 milliamps. Or no, you know what I'm trying to say. 200 milliamps. I think that's going to be about it though for this power supply. I do have a 60-volt power supply, but I don't know about that. Don't know, but I know that this light is so bright because I'm putting 25 volts in. It has nothing to do with the rotor, and it's still flashing pretty bad. but it's a lot better than the big one for sure. I don't know if the, I mean, with the SG, I'll probably be able to use the little one to do the batteries. But like with this coil, these little magnets aren't going to do anything. They're not going to make any electricity. Let's just put that. Okay, it's making about 12 volts where it is. Oh no, it's hooked up to, yeah, my bad. The battery right now. Mm. 1 volt where it's at. 2, 3. Okay. All right, we're generating about 22 volts. That's not bad for that little disc. Not bad at all. Yeah, that's good. It's stable at 22. That's awesome. So I think that will, especially with the SG, work quite well. All right, let me get transistor for the other SG. It'll be just a moment. I'm glad I got 2 flats of these little things. Here we go. So it's a 2SC3320. I don't know if we're going to be able to do this just yet, but I'm going to hook it up and get the transistor in there. Perfect. Just gonna loosen these up because I mean I would do it right now, but like I said, my identical coil is broken. I have no means to make more coils right now. I have 26 gauge and 32 gauge in some sort of bulk fashion, and that's it. I have a bunch of little rolls, but they can't make this coil. So, and I'm broke as shit, so that isn't going to happen anytime soon. All right, but at least I got what I got. All righty. Yeah, I think the two combos here added up to be about 135 out the door. So it's a good investment, in my opinion. If you're into doing this stuff, check out the K Energy store. It is chock full of cool stuff, man. It's good. Good place to shop. All right. Like me, if you want a rotor, 100% infill, let's say at 100% infill at 8 inches, that would cost, I want to say $85. Because the material is roughly 30. I don't buy cheap shit, so it's $30. And then it's and you know it's going to end up being about 2 pounds just the plastic, so you got to pay for shipping. And so yeah, about $85. And then you know the time I put into it. You can send me a design if you want, your own design, but the material and the time is going to cost about $85. I'll even give you 2 bearings. You can throw those away if you want. Actually, no, I can't do that. I want to do that. So let me rephrase it. I want to give you what you need to make it work, but I can't. All I can do is make the holes the right size. I can do that. Then I can print it. And then, you know, like formers. I can print formers too. All I need is the, you know, what do you call it? The G code, the schematic for your specific former, and I can print all that crap out too. And it's good stuff. I mean, crap is good. I don't mean it in a bad way. Yay, we got it. 20 volts this time. Just need a little bit more momentum than it got going. Sweet. Now, if we do a double SG, I kind of want to do that right now before I get off here. Definitely before I leave. Man, it's like my best bifilar coil. It's 20 gauge and 30 gauge. Like perfect, man. And see if I can get anything else real quick. Oh, nice. It's not the same size. It's got a 20 gauge in there. Or is that a 22? Let's see. Maybe it's a 22. Mm. So it looks like we've got 26, 22, and 32. Maybe. At least this one's got a trigger in it, so that's good. Mm. Mm-hmm. Mm-hmm. All right, we're getting there. Right. So I think I have to do a little bit of connecting. So it looks like there's two strands on each side of 32 or 26. Maybe it's 30. I'm not sure, actually. 26 and 22. 30, 26, and 22. All right, so turn this all the way up to the connector button right there. Just to be certain. Bingo. And the next one. What's going on there? That's what it was. All right. I'll be right back. All right. Which I didn't take the mic in there with me this time. Yeah. Is this a wow? All right. So we got our ends. Now we need to get it there, and this goes in here like this. We need to connect. It's a 4-filer coil, so it's not exactly the same, but I think it'll do with a trick. Right. So where in the heck did I just had it. Where did I put it? Here we go. Like I don't know the story of Peter Cottontail. And then I will just say random off the wall stuff like that. But it actually has quite a bit of meaning. Believe it or not. Like Ripley's Believe It or Not. Got that two-sided mirror, so like you can see through it on one side but not on the other. You got all these people like walking up to the mirror and they're grabbing themselves, giving the mirror the finger. They're like, oh, and then there's a bunch of people on the other side just looking at them, being like, ah. Oh God, it was great. You know, punk kids like to do that. They like to grab themselves and give people the finger. It's like it's what they do. All right, now we gotta get two ends. So this this. We're almost halfway there. So I need this. Shoot. Good. All right. Now I didn't realize how easy it was to put together the Litz wire for the rodent coils. Until I did it myself, I thought it was going to be a real pain in the butt to put all the ends together. Not so bad. Not so bad at all. Actually, it was pretty fun. I went step by step like clockwork. It was awesome. Mm. I might actually have to get some thicker wire to put in these holes. Clip it all together. Oh, I got it. Nice. Oh, if this thing fires, dude, I'll be so happy because it's old and it's very experimental. All right. Yeah, I was happy to be able to do it earlier today. Honestly, I got, a little bit of time here in the morning to do it, and that's awesome. All right, so we're gonna switch off. No, well, we're not gonna switch off. We're going to run in series and use the power supply for right now. Until I get a cap dump, this is how we're gonna play. Because I've seen the cap dumps work, and you know what? You're absolutely right about those. It's a necessity for charging the batteries, or he wouldn't make them. You can tell by somebody's workstation, kind of how they're going to build stuff. I don't know. I guess it's you can't really tell what I'm talking about by the table. You can tell by what's on the table and where it is. But the table itself is it's not, dude. I mean, just because it's an eyesore doesn't have anything to do with how I'm going to build something. Got that. It's weird because these little coils right here, they're just 2 layers of 20 gauge wrapped around a soft iron core. That's all it is, and it literally got that little disc going about 3,000 RPMs. But the coil is or the field, it's very strong and very acute, so it's small, but it's powerful because of how much iron is in it. What load do we want to put on this SG? We're not going to charge any batteries right now. I don't have the tools to charge battery right now. I don't have the cap dump that I need to do that, so I'm not even going to bother. Because I've done it 100 times already, and I get so excited. It goes up, and then you turn it all off, and it goes way back down. And you get very little charge that is kept. And it could be in my multimeter, but still, it always goes back down to the same amount, whether or not. But all right, I guess we could hook the battery. I don't know. Can you charge battery in series? I don't know. Never tried it. All right. So we almost got all of our ends in. These are much easier to work with than, say, a 32 gauge strand. Right. Hmm. You know, I really want to have a toggle switch. This is going to be like wazam. It's going to be 24 volts. Like as soon as I turn on the switch, it's going to be like a cap itself. Well, it'll be a little under 24 volts. I'm going to take out these longer ones. You know, the one thing I don't like about it is that it's kind of backwards. everything's kind of on the wrong side to go with everything that I have. So it's kind of a little clumsy, I should say, but it's all right. It works good, so I'm happy. Just me working with it is clumsiness. There we go. Whoops. Man, I don't even know what the hell I just wasted all that time. All right, we got the wrong. There it is. Yeah, man, I'm going to be on the first flight to Mars, so don't even worry about it. That's commercial flight. All right. All right, so that one has a load. This one does not have a load. What should we load this with? All right, it looks like it's going to work too. Huh, that's too high now. That little steel ball bearing right there is wicked. It's wicked. And it works rather well. Nice. All right. Boop, 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 boop. All right, let's turn it on and turn it on, and we'll see it go really, really fast real quick. Or is it going to stop? Holy cow. It's weird. That is so weird. It's like this light is being affected by this power. Watch. Oh, there it goes. There it goes. Oh, yeah. Like 1300 right now. And that's weird. That's 24 volts. Hmm. 1320. I think it's a gem, this little thing. I'm glad I built it. Needs to loosen up a little bit, though, I think. Maybe some graphite powder. Now, if that coil is actually going to be the one that I use for like the final build, I don't think it will be, though. It's like they're too different. They're not the same coil at all. Now, this core should go right in. It is going to go right in, but it's too right in. You know? About 1,000. So the actual build will be one of these per power supply, or two of them. I could actually get two more and then run them in series 24 volt. I think I don't know, with a cap dump, I don't think it's necessary, but without, I don't even want to say without a cap dump. We're not even going to try it. I just should go faster with more voltage going through it. That's awesome. And these little transistors aren't as bad as, you know, made them out to be. Wow, that's some inertia right there. All right. The green monstrosity. I'm sure there are a lot of reasons why this disc is the fastest, but none of them are really talked about as to regards to speed. Look at that. Frickin' A, dude. Wow. Oh, wow, dude. So this is a double pounding. Okay, I got them lined up on the magnets, or I can line this one up offset, and then it'll pound twice. Right now it's just pounding once, twice as hard. All right, what law am I breaking here? Because it's at 1400 right now. $16.27. Woo wee! That's nowhere near letting up yet. Holy cow! Solid, solid. That's solid, man. That's not going anywhere. I love it. 1690, 17 Hondo. And there is one other thing that I wanted to kind of show you guys, and I think I'm going to use the little rotor. And this thing is awesome. One more attack and we're going to shut this down. 1715. All right. red. I don't know, that is totally unnecessary to use a transistor with this. Awesome. All right. We don't necessarily need this. We need this. Let me get the camera set up right. See if this is going to work real quick. Getting some bad arc in here, like really bad. Dang. It's hard to get a good position. I definitely don't want to touch that with the power on. Nice. Ground to a screeching halt. Wow. There we go. I was on the wrong side. But I don't think that switch is going to make it go very quickly. Ooh. That's definitely sticking. And I don't think this is going to, well, there's a possibility that it could go over here. Yeah, everything's the wrong kind of size for what's going on here. That might be good though. Let's give it a shot. There's an idea. Put a big flipping resistor in there. Let's see what happens now. Now it's sucking it all up, man. We're at 24 volts. And put it all the way up to 63. See what happens. There goes the resistor. Oh, not really. I love this thing though, man. It's like archaic. Man. It's like very cool contraption. Virtually works how a switch would work. But it has nowhere near the frequency of a transistor. At least not where I can get it on this one. Wow. I think I just blew my clip. Yeah, this little devil is really tricky to work with because it's virtually just an iron core. With the give or take 2 layers of 20 gauge on it. Very delicate or hard to work with. So this one here looks like I got a 22 gauge and a 26 gauge strand connected in series, and then a 30 and a 32 gauge strand connected in series for the trigger. I know that's kind of weird. I don't know why I made that coil, but it's working out okay. Wow. Yeah, that one on the side there, I was up working at about 25 volts on the far end, and yeah, several things popped. There's a large arc on this. The resistor fried, and this cable right here, I think the end right here popped, like right in there, disconnected. So, oh, dude, there you go. I never really tried it with the small one though. I've always used it with a bigger rotor. Works really good. Because with that switch, it's exact, and the amount of magnetic activity is very important. And I'm telling you right now, I do not have a rotor that will go faster than the one that's going right now. I don't. Doesn't matter which way we hook it up. And I'm telling you right now, it's because of how much it weighs. And if I made this one that size, it wouldn't work at all. So, I mean, no. It's not only the degrees of separation, it's also how far apart the magnets are. And those two things are very different. And it all depends on the diameter of your rotor. See, because a 10-inch diameter rotor and an 8-inch diameter rotor, 40 degrees of separation are going to be different distances apart. Yes, they will. And I think 8 inches is perfect for 9. Perfect for 9. I know. I can feel the frustration ramping up. It's like, how the hell is he doing that, man? It's like, why? Why? Well, it just is, man. Let's see how fast it's going. 17, 20, 19, 17, 20. So I've had it going way faster than that. Let's see if we turn this off. Wow, I see what the difference is. You take that air gap away. I might have mislined that up, so we'll see where it's at now. 1734. So getting it up really, really close slows it down a lot, especially with the air coil. It either stops functioning or there we go. 1800. There it is. So I'll see about what I can do about getting a cap dump in the next month or so. Maybe 2 cap dumps. Or learning how to make one. And we'll get this working the way it should. With our 2 magnet rotor, our 90-degree coils, and we're going to try and virtually just swap energy. It would be good if we could get it up to where it's at right now, 24 volts instead of 12. I don't think 12 will do the trick at all. I don't think it'll work. But with a cap dump, that might be totally wrong. I think if we can charge a cap dump and then have it all charging the battery at the same time, we'll be up by a little bit. And I mean a little bit. I mean, it'll happen really fast, but you got to charge up the cap dump. And in that time, you are using your battery to do so. It should happen pretty rapidly, though, depending on the size of the dump. $19.13. Woo! I'm backing it out a little bit using more of the magnetic flux field. 1970, dude. We're gonna hit 2000, no problem. Maybe, yep, 2000. Woo! 2000 with the 9 magnet rotor. That is a weapon right there, man. That'll go through the window into the next neighbor's house and like keep on going, man. It'll keep on going. I'm glad that steel is strong. It's still soft metal, but it's strong. It's flexible too, so. $20.30, baby, that's still going up. All right, we're gonna cut this. That's actually the fastest I've gotten it to go so far, $20.30. Wow, man, that is not gonna stop. So cool. And all I had to do was make it 100% infill. Seriously, I mean, I could run this with 3 magnets, I think, and it would be the fastest one then, right? As long as they're all 8 inches, I don't see why that makes a difference. Man. I think we already did this. This one. Let's do the 3 magnet one. You can't really do 2. Well, yeah, you can. You just have to line them up. You can't do a alternating one. Oh no. All these wires got caught up when I moved it. We're gonna try an off. We're gonna go one bang 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 instead of boom. You know, we're gonna go bang bang instead of bang, and then we'll move it back. We're just gonna test it out and see. Well, 630 so far. Yeah, it's just so lackluster after seeing the other stuff. Don't know what the problem is really. I'm not saying anybody's like doesn't know what they're talking about, because I know that's right, because the coast in between is important too, and when there's more space in between each magnet, you get that coast effect. So, but no, one constant will always be that the rotor will be 8 inches. I mean, the little ones are fun, but yeah, it's a whole different ball of wax, and I'm not interested in trying to fit the mold like that. I like what I like, and that's that. Now, I do want to get the self-charging thing hooked up, and I don't think, honestly, that it'll work. I think you're always going to be, unless maybe at 24 volts it'll work. I knew at 12 that it didn't work at all, but I didn't have a cap dump. So, but I'm also willing to bet that the cap dump, I mean, there's probably lots of protocol that goes along with keeping batteries charged up, you know, like where to store them, yada, yada, yada. Don't have your multimeter, leave your multimeter hooked up to the battery. It'll drain it, you know, all this stuff that, you know, people take for granted pretty much is really good information. It's great information. So thank you, 007, for filling me in on those very important facts. Because when like the 100th of a volt counts, where 100 of a volt counts, all the information matters. It all matters. How much weight? How much does the rotor weigh? It's a freaking matters paramount, dude. How much is it? A piece of paper or is it a rock? You know, it matters a lot. And everybody seems to like leave it out. Like it doesn't matter. Like it's all about the magnets. And it is. But I say it's more about the coil than it is about the magnets. The coil is the heart of the motor. That's why when you go for the positive and negative terminal of the motor, it's usually one, and one end is part of a coil and the other end is also part of a coil. So I have a cap bank. I have two cap banks right there. One's got a bunch of rectifiers hooked up to it as well. Woo-hoo! So next time, I promise, I'll be more engaged with everybody. I'll have the display up on my screen here, and we will be able to chat more vigorously about whatever. As long as we can keep it pulse motor related, I'm a happy man. We all like it better when I'm happy, right? Yeah, but I don't think it's like mud in a bowl. I mean, could we use mud in a bowl, or does it have to be attached to the ground itself? Or does the mud have the same frequency as the mud in the ground? Because if I can bring it inside, man, that would be ideal for me. I don't want to be outside in Michigan weather freaking playing with electricity. That's not smart. All right, so that is that. And we'll put this on the off, like right here. Move this up a little bit. Oh, no, I have to move it back a little bit. Now this should be have a different effect. This is bang bang instead of burn again. Yeah, that's already up to 1,000. That's amazing. Because it's so heavy. I mean, geez, it's freaking like 4 pounds. So I got my shopping list. All right. Yeah, I'm going to do an intermission. I'm going to think about what I'm going to do here. Do next, I should say. I like having the two SGs working, though. That's awesome. I don't know, man. It's a whole other level of dumbassery. What am I talking about? Let me think here. This stuff fascinates me, man. It's not like, and obviously because of the way other people have categorized everything, this is not what people would consider to be like the cutting edge of this niche. This is like, to coin a phrase, 1960s. I mean, seriously, I mean, if your objective is to discourage people, keep talking shit then. I try to encourage people by talking shit, and I make it plainly clear that I am encouraging you to go out and do what you think is cool instead of sitting around just talking about it. I encourage you, not discourage you. I encourage you to go out and do things. Like, no, man. And I'm sick and tired of, people sitting on their butt and blaming it on the Matrix, man. Forget it, dude. Get up. I love what I'm seeing. I love what I'm seeing. I think people have been listening to me, and I really appreciate it because I'm not an asshole. I only look like an asshole. I only sound like an asshole. But what I'm really doing is I'm encouraging people to get up now and do stuff, because I'm not telling you what to do. I'm not telling you that you shouldn't do something. Oh my God. No, man, enjoy it. Have fun. Just blow stuff up. Don't discourage me, because I will get pissed. Isn't that sweet? That was awesome. Hope you could see that. Maybe we should get it up on the table real quick. Oh, it's smoking. Yeah, that was powerful. I could actually feel those. So, the plasma balls, that's cool. The Tesla coils at a smaller level, that's cool. I like playing with the bolts and everything and having my little tools and being able to make it stretch out and all that and play with it. The things that I've been seeing online here, these are not toys, okay? The big ones with the foot long spikes of electricity that are freaking 2 centimeters thick. Stay away from that shit. That is not like don't do it, but like do it like like it's being shown on YouTube. Just get away from it. Turn the lights off. turn it up. Yeah, but you know, you can't do it like I just did it with those things, or you're gonna fry yourself. I don't even know really with the spikes that I've seen if you can touch those. I'm thinking you can't because people stand pretty far away from that. But I can touch these little ones. I think I can see smoke coming off of it, but I mean this one is totally adjustable. I can go minuscule power, high frequency. I love it. It's awesome. Well, I don't know. I'm really passionate about freedom and being able to do things and not feel like you're stepping on people's toes doing it. I mean, it's not even fair that it's like you need to go. I don't know, man. You need to find something. I need to find something. At least, if not you, it's got to be me because something's got to give. Because I'm trying to get out there and get to know people doing this stuff and whatever. And then there's it feels like a generation gap. Like all the numbers and the math is back here and just winging it and doing it is over here. And there's got to be some kind of, these people can't be telling these people that they don't know what they're doing. And they really can't do that. That means that these people end up being useless because, I'm talking about useless to the people over here because in this right now, people are shunning people that don't fit the bill, their bill. It's like, hey, dude, what are you about? Oh, you're about that? Well, I'm never going to talk to you again. It's like that bullshit. It's like, if you think that's going to make me go away, you got another thing coming. Wow. All right, we're done with the pulse motors. All right. Really appreciate everybody coming in, listening. And yeah, I know the frustration bell is knocking in a lot of people's heads. What's this asshole talking about, man? What's he talking about? It's all BS. Well, I got a hammer too. Would never lie to anybody, man. I would, if I don't know what's going on, I'm going to be the first person to say, hey, man, I don't know what the hell's going on here. But if I do, and I'm relaying a message that somebody else gave me, and yada, 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 I think I know what's going on. Does that mean I do? Probably not. Probably not. As soon as you know you have it all figured out, that's when you don't know shit. You don't know anything then. You think you got it all figured out. That's a telltale sign that you need to reevaluate. Oh yeah, man. And all the prison talk, man. Oh my god, dude. Talk like a frickin', like like you're never gonna get out of there. That's how you sound. It's not like I don't cuss. I cuss every once in a while, but the people in prison, they cuss a lot. That's all they do. I'm not saying everybody in there, but I mean, it's pretty profound. So if you like to cuss a lot, there's a place that is more than willing to accept you for who you are. But me personally, I think cussing is disgusting. It's funny, maybe if you're drunk and you're on a tangent and it starts flowing. That kind of stuff is okay, man. It's all right. It's all right if you do it to me, is what I'm saying. But if you don't just go out and like, oh my God, dude. And face tattoos are a bad idea. That's my opinion. And a lot of people probably won't like that opinion, but I don't think face tattoos are a good idea. Mm. You know, just for the hell of it, I think I'm gonna do it over there. We're gonna give a whirl. I wonder if this rotor will work with the counter rotator. I wonder. I will always have a segment that I like to call Pearls of Wisdom nearing the end of my live streams. I always get a little off track because I am bipolar. I'm passionate about a lot of things. Oh yeah, we got the toroid. There it is. Mm. Now, I don't know how juiced up this bad boy is, but we're going to find out. This is the stator of the counter rotator. Stators don't usually move. That's why they call it a stator. Oh, man. Here it is. Yay! So we put this little flange like right there, maybe a little lower, just so the bottom can still spin freely and you can put the disc on the top. All right, now to ensure good spinning, we put this bearing on there to give it the clearance it needs. That's really close, but we'll see. Then we got our, I really wonder if that 9 magnet one will work. But I'll test that out. When so the battery still got some juice in it. That's pretty neat. Let's try the other one now. Wow, this is going to be awesome if it works. I mean, looks like it's working. Maybe. So I say the 3 definitely works way better with the counter rotator. But we'll give it some time, and I think it'll speed up a little bit, but I don't think it's going to speed up like the 3 magnet one will. All right, I'm surprised the mic lasted this long. Not at all. All right. So this looks like the vehicle's max speed with this engine. And that's probably because of the weight. This one is 25. It's a lot lighter. These magnets are a lot powerful, more powerful. And there's more space in between the magnets. Thinking that's why less magnets are more better for speed. Woo! That's pretty. That was going, see, and then there is a weight disparity, which I need to fix in the stator. The rotor is pretty good, but let me show you. It's good. Right here, you got the battery and the coil. Here you got the battery and the coil. Trigger coil doesn't really work. It doesn't matter that much. And then right here is the disparity because you need like a battery worth of weight right here. And all you have is a breadboard and a couple transistors. Now I have a solution, but I don't know how to put it in there. Got another battery pack that makes it 36 volts. And you know, just put it in there somewhere. Maybe redo it and put the battery in first and then put this like against the battery. That'll probably work. But then it will be going like ridiculous amounts of speed, man. Like hopefully it'll be more balanced. It's going that fast. Hello, hello. What do you want to figure out? Here, let me take this off of here so that I can interact a little bit with you guys. Oh, this isn't going to work. Well, maybe. Let's see. There we go. I gotta, because the phone's plugged in, gotta reposition it with the cord, which is difficult. All right. Rumpelstiltskin, what's up, my brother? Matthew Wood. Okay, this is a counter-rotating pulse motor, if that's what we're talking about right now. I'm not trying to do anything. I'm not generating electricity, really, not right now. I mean, electricity is being generated, no doubt, but I don't care. I really don't. I love watching things spin. That's what we're doing here. We're making all this stuff spin and spin really fast. In my mind, there's a debate going on because there's a lot of information that isn't out there about magnets, how many magnets in the rotor and how fast that rotor will go. Okay, so over here we got 2 magnets. That one went in about 350 RPMs. And this is like all with the same amount of voltage. And all these discs are 8 inches. The only thing different is the weight is different in each one. Okay, and that's the part of the rotor that everybody tends to leave out, except one of my buddies. I used to work at Meyer, and he would come in all the time. He'd be like, "How much does your rotor weigh?" I'm like, "Why does that matter?" It matters because of inertia and forward momentum and force and how easy that happens. This rotor right here, 2,000 RPMs, 9 magnets. This one right here, probably around the same. I got this one going around 3,000 with a Litz wire coil. So we're testing out how fast these things can go under the same duress and the same voltage. I mean, you would say, if you want the 2 magnet rotor to go faster, make the rotor smaller. Okay. I did that. It didn't go faster, but it went faster than it normally does. And that's not even true. With 6 magnets, this thing was going like 3,200 RPMs. With 2, not even close. Off of this particular build right here, with the 3rd one, so it was like 3. And it would go with a reed switch, 3,200 RPMs. Unfathomable. I don't need contact plates, man. I have contact plates. I made God, where'd I put them? Yeah, I know exactly what to do. You make 2 plates, one for the positive, one for the negative. You have your 2 brushes or 3 brushes, depending on how many transistors you have hooked up in there. And you could even make an additional ring for each transistor. And then you have your brushes just hanging down, and it'll work. Yeah, no, I don't use the plates for charging. I have a charger specifically for these battery packs, and all I do is unhook where it's clipped, just the 2 ends, and I charge them one at a time. You can't charge and discharge a battery at the same time. It'll blow up. These batteries will. So the only way that I know how to make a self-charging pulse motor work is to have 2 magnets on the rotor. And I mean, I guess there's a mathematical equation where you can have more or less, but you want your coils at 90 degrees, you want your magnets at 180. So when one's charging, the other one is not. When one's being used, the other one is not. Okay, you have to do it that way. So contact plates won't work to charge it. Because when it's, well, if it isn't moving, I guess it would work. Wow, that's great. But when it is moving, you don't need the contact plates. So yeah, man, actually, you know, yeah, that's true. But that would be taking a step backwards in my mind. Especially if you're going to put this on the shelf, man. You can't have commutator plates just out there. You know, battery operated is the ultimate goal. And yeah, I do understand what you're saying about and I had it running that way before I put the batteries on there. But the ultimate objective is to not have all the extra stuff. And I mean, it is a weight. You're right about the weight. It is a problem. But I think by putting another battery in there like so, for the most part, I need to get those because I know exactly what you're talking about. And I used to run this thing exactly the same way you're discussing it right now. And I got bored of that. Thank you. I got what you were saying too, and I've been trying to convey that as clearly as I could. It'd be a lot easier for me to do if I could find the freaking plate. But yeah, man, that's how I first, because I have these power supplies. Well, like right there and right there, and that's what I was using prior to the batteries. So I had to have the commutator plates. But yeah, got me thinking though about how I can change the weight on there and make it more sturdy because it's literally like took the wheels off of the table and flipped it on its flipped it over. There's no wheels on the table though. It's like the wheels fell off the bus. Let's just put it that way. And I'm pretty sure there are other ways to, do stuff. I just don't know what they are right now. Just got started doing it. I've only been doing this for 2 years. And quite literally, the only like every counter rotating pulse motor I've made so far is operated and functioned perfectly. Except for, disparity, like the weight differentials and everything like that. But they do what they're supposed to do. I mean, like to a 9-volt battery or something, right? Or like a 12-volt. Oh man, yeah. Yes. Different batteries would be awesome. But right now, there are two 12-volt battery packs hooked in series. Making it 24 volt, 24 volt. Can you hear me now? Can you hear me now? Just curious. I gotta take that off of there. All right, great. Yeah, my mic only has about 3.5 hours life on it, so I usually put it on so that I can walk around and you can hear me. But all right, so yeah, there's that one. Here's the one with the commutator plates on it. All right, so the coils are in the center in this one. The magnets would be on the outside. Let me get the dome for it real quick. It's for that blue thing right there. So it kind of looks like that. And this goes on there like that, and it has 3 magnets about that size in there. And there's a reed switch in there, and then you clip negative to this one, and the positive to this one, and the positive one is right there on top of that magnet. And you just need to adjust your brushes. See, the positive brush is really good. The negative brush right here needs some work. Yeah, no problem. And for the most part, I agree with you. Battery operated is a totally new frontier for me. I just decided to go for it, and it worked. All right. Well, thank you very much, everybody. I really appreciate you coming in, showing your interest. I would be doing live streams pretty frequently. I have lots and lots of videos. Please like and subscribe. Check out my content. Not all of it is the greatest content, but there's about 3,000 videos and shorts and all kinds of stuff about this stuff. Starting all the way back when I didn't know anything till right now, where I know a little bit. Yeah, probably better brushes. Not just fixed ones, but like real brushes designed. This is 26 gauge wire. I think the other one's 20 gauge. All right. Well, I gotta go. Thank you very much, everybody. Peace out. Have a great day. Please like, subscribe, and hit the notification bell. And I'll look forward to seeing you again. Bye now.